Hello everyone, welcome to In 5 Minutes. We are going to study the next property of discrete Fourier transform. It is conjugation. Consider if the DFT of normal discrete sequence, that is x of n is x of k, then the DFT of n-point discrete sequence, which is a complex, that is DFT x star of n, is equal to its conjugate sequence, that will be x star of n minus k. This n minus k will be proved similarly on the basis of the previous proof, that is by substituting e raised to minus j 2 pi n, that is equal to 1. So let us prove this. Consider DFT of x star of n is equal to, using the general formula of DFT, summation n is equal to 0 n minus 1 x star of n e raised to minus j 2 pi k n upon capital N. So now if we expand this term, you will get the complex number. So better we write in whole bracket form. But while expressing whole summation as a complex number, this exponential term will become positive. So we will get summation n is equal to 0 n minus 1 x of n e raised to j 2 pi kn by capital N the whole star. Now for bringing this term n minus k, we have to multiply by e raised to minus j 2 pi n. So we will do this. Summation n is equal to 0 n minus 1 x of n e raised to j 2 pi kn by capital N into e raised to minus j 2 pi n. Now we will take the common terms and multiply the exponential terms. So finally we get summation n is equal to 0 n minus 1 x of n e raised to minus j 2 pi n bracket n minus k upon capital N the whole raised to star. Now using the definition of DFT, we get x of n minus k star, that is its conjugate sequence. Therefore it can be represented as x star of n minus k. Now we move on to the next property, that is circular frequency shift property. This property states that if a discrete time signal, consider x of n, is multiplied by e raised to j 2 pi m n upon capital N, then the DFT of this whole term will be equal to x of k minus m, that is shifted by m units. So let us prove this. Using the basic formula, DFT of x of n e raised to j 2 pi m n upon capital N is equal to summation n is equal to 0 n minus 1 x of n. Now we have to prove that it is shifted by k minus m units. So we have to bring a term extra, that is e raised to j 2 pi m n upon capital N into e raised to minus j 2 pi k n upon capital N. We already know that this term will be 1. So after multiplying and combining these both the terms, we get summation n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi k minus m into n upon n. Then using the definition of the DFT, we focus on this term, that is k minus m. So we express this as x of k minus m. Thus the property is proved.